All right. Hello, folks, and welcome to the binding status. We are back for another episode this week, and it's going to be a fun one. It's going to be focused a little bit more on contributors rather than end users, but it should be illustrative for pretty much anyone who's using Crossplane because you're going to get a little bit of a behind the scenes look. There's also been a lot of folks in our Slack channels who are wanting to either have support added for a new service or they're willing to contribute themselves to be able to add it. So we're hoping to break down some of those barriers to get folks contributing and understanding what's going on behind the scenes so we can continue to grow out support for resources across different cloud providers. So before we get started, I want to take a look and see who's joining us today. It looks like we have a few viewers trickling in right now. Jared, who is one of the founders of the Crossplane project, is joining us today from Belgium, usually from San Diego. So we're getting a little more international flair from him today. And we'll continue to look in the chat for any folks that are joining over time. I know a few folks mentioned in Slack that they would be here. David Lopez looks like he's joining. Welcome, David. As we get started here, I have the privilege of being joined by Muvaffak today, who is one of my coworkers at Upbound and a fellow maintainer on the Crossplane project. Muvaffak has done a lot of work around defining what it looks like to have mature resources for Crossplane providers. So we have different providers for different cloud providers, but you can really build them for anything. And we have a common set of basically requirements around what an API looks like when we add it to a Crossplane provider. And Muvaffak actually has a great document on that he wrote up that has a lot of those specifications. So we're really glad that he's joining today. And we're actually going to be adding support for a new resource today, which is a Google Cloud PubSub, specifically the topic resource, which is kind of like the main unit of service there. And so we're going to be going through that. Muvaffak is going to be telling us all about it. But Muvaffak, do you want to take a few moments to kind of introduce yourself and tell us how you're doing today and anything else that you like?
Yeah, thanks for having me. So yeah, I've been working for about a year now, almost, and it's been like full on Crossplane. And I've worked like in a lot of different areas of Crossplane, like managed resources, composition, and all other things. And as you mentioned, like we've got a lot of folks like asking for how to implement a new resource. Like we've got some guides, like service developer guide and like other API designs and stuff. But like sometimes it's just easier to watch a video and like see how everything is working and like someone to talk about stuff while they're implementing. So like that could be fun and like beneficial for people who want to implement it.
Yeah, for sure. That is a great point, and I definitely think video is one of the easier formats to consume. So I'm excited we get to do this today. We've also, just for folks that are joining and are interested in this, we've also done a couple of sessions in the past for more formal contributor onboarding and maybe walking through a specific resource you'd like to implement, and we are more than happy to do that. So jump in our Slack and let us know if you'd like kind of more of an individualized overview. But I think today is going to serve as a good reference point for a lot of folks. And because we're doing live coding today and we're going to be doing a fair amount of work and actually at the end opening a PR, hopefully, for the issue for this and getting this in for the next GCP release, let's go ahead and jump right into it. Muvaffak, I'll let you kind of drive here since you're going to be doing most of the work. So you can go ahead and share your screen if you like. And I think we're going to start by maybe looking at the issue and looking at the API that GCP exposes for PubSub.
Yeah. So let me share my screen. Okay, so usually, you would like to implement a resource, and the first thing you would do is basically search for the issue. If there is, you can just comment on like can I take this, and like ask people like if anyone else is working on it, and then like probably either me, Daniel, or like some other maintainers, they would encourage you to take it. So this is the, let's say I have assigned myself, I got the permission and I set myself permission. And then I am starting by looking at the API to see like, how it looks and like, what is the one resource, like one CRD that I'm going to implement, how it looks like. So just a quick overview of like what Cloud PubSub is. It's basically a messaging queue, and like, it's used for a lot of use cases, but as main thing, you create a topic, which is what we're going to do, and then publish stuff into that, or like read from somewhere else and all that stuff. So we will implement the topic resource. You see the API here, it has a create, delete, get, list, and usually like for some cases you don't have like full CRUD methods. In this case, like for example, topic snapshot doesn't look like an actual resource here, but like on the actual snapshot is one. So this is kind of how you can see like what to implement and stuff. So we want basically the CRUD methods to exist for a resource to be implemented correctly. So okay, so as you know, like Crossplane is written in Go, so we will take a look at its Go reference, and this is its package. There's one caveat here, like before live stream, when I check, if we use the latest, it updates like a bunch of other libraries and breaks some things. So we will use the version earlier, which is compatible with all other modules.
Yeah, for sure. I think that's a good point, Muvaffak. And I actually ran into this recently while working on EKS for AWS. And in that case, we were using a couple versions older of the AWS SDK, and there was actually a feature that I wanted for EKS in the updated one. So in some cases, it may be worth kind of like the toil of adding and updating existing things. In this case, it just meant updating some unit tests and that sort of thing. So it wasn't a big diff, but a lot of times it's lower churn just to go ahead and use what we have there and maybe leave kind of doing the version bumps to the maintainers.
Yeah, exactly. I mean, like I've seen like Cloud SQL and like GK cluster APIs being changed, and like having to update them in that live coding would be some waste of time. Okay, so we're gonna take the 131. So let's see. So we are in our provider GCP, and I just make sure that we've got the latest master and create a new, let's say, topic branch. And then, so this is the provider GCP. I'm using Golang. If you guys are familiar with it, it's essentially an IDE. So we have seen the library. First thing we need to do is basically go get it. Go get this version to be added as a dependency. And we got it. It's been added, and there's not much other change in the Go mod file. Cool. So first thing I'm usually doing is to create the CRD. So we were using Kube Builder, so we are going to create the structs, Go structs of the CRDs, and then actual YAML CRDs that will be deployed to Kubernetes will be generated automatically. So in this case, in APIs, and there's also the thing about the API groups. See, we have like cache, and under that we have got cloud memory store. We've got container and GK cluster. So this is like this should be similar to how GCP groups their resources. In this case, it is directly PubSub. So our API group is PubSub, and our resource is topic. Okay, so the easiest way to get started is basically like copying another resource into this folder, and then make the changes. I mean, we have plans to automate this, have a boilerplate for adding new types, but like it's not there yet. So we will just manually change some of the things. CP PubSub
Yeah, for folks that are familiar with KubeBuilder, it's kind of a similar directory structure with a few differences. The directory structure is pertinent for generation, but it's also not special in that regard. So you could actually do things differently, but for the sake of kind of maintaining a clean code base, we prefer to keep them pretty standard. Muvaffak did mention there that we like to mirror the cloud provider, kind of the package name. We like to mirror that with our API groups. In some places, that's not the case because it's older resources, and we've kind of recently moved to making sure that we match those exactly. For the context, before we were trying to use kind of like more general names, so like use a database across all the providers. Now that we have kind of a layer of abstraction that you define over, and we're trying to be more one-to-one with the cloud provider, it makes a little more sense, especially if you've already used the cloud provider APIs, to match your group to that package name. So you may see some kind of like legacy packages that will slowly be moving over time, but as we move forward, this is definitely the right pattern here.
Yeah, exactly. So I will just go over those Go files. So you see a few generated files here. We can just go ahead and delete them because they will be generated automatically anyway. So this was doc, this is register. There are a few changes on strings here. See, so this will be, so the resource we've copied over is service account. And so that's what we're changing. And okay, I will come back to this one because it's an existing struct here. So let's change this name. Cool. Okay, so the structure is that we've got main, like it's called root in KubeBuilder, root struct here. That will be, the main struct that will have all the parameters and stuff. So I will just, change this to topic. And for a while, the linter will get crazy. Okay. And we can just, delete these. So these are printer columns. That's like, what you see when you do kubectl get. And like you've got, columns. These are like, specific to these last three ones, specific to service account. So we can just delete them and we can come back and see what we can supply there. And public status.
Yeah, so what Muvaffak showing here is, as he said, just kind of refactoring a bunch of this from an existing resource.
Yeah.
There is, as he said, also some work being done to template this out. So you just say, create new resource topic, maybe provide v1 alpha 1 in the group name or something like that, and we'll just generate these folders for you, which is a little bit faster. That being said, there's also right now a provider template if you're bootstrapping a new provider that will bring in some kind of like more bare bones templates that will allow you to maybe have to rename a few less things, because this part is obviously never fun, but it doesn't take too much time right now, and it might actually be useful to look at what another resource is doing here and how you want to adapt that.
Yeah. So let's go over the structs here. Spec. So this resource spec is the standard inline struct that we have coming from Crossplane runtime package that we use all over providers. And for provider, struct is what is sent to the actual provider, which is GCP in this case. So for now, I will just go ahead and delete it, and we won't have anything. Let's say something like this. And we have the observers in the status. We've got, again, the resource status that is standard, which has condition status and binding. In this case, by the way, there was connection secret reference, provider reference, and all that stuff. So for the observation, we also remove all of these state of
Yeah, so those embedded structs that Muvaffak was talking about there, those allow us to use shared reconcilers, which we're going to talk about later on, that basically use a general pattern for informing users of the status of our resources and also how to connect to the cloud provider and that sort of thing. So instead of implementing these separately for each resource, we just embed them in there. And I'm sure we'll see in a minute here how that gets translated to the actual CRD that's generated, right? Because we're going to be creating a CRD for this that's generated from the Go structs. And that's what some of those tags, those queue builder tags are doing. So for instance, there's one there on the topic type that says, I think, resource scope cluster. So that's saying, generate a cluster scope CRD. So when you create instances of that, it's going to be at the cluster scope. All of our managed resources, which defining managed resource would be just a CRD that represents a type of external infrastructure. All of those are going to be at cluster scope. So that's something to keep in mind if you see that here.
Yeah, exactly. Yeah, so we came back here and like updated here topic, but there is an error here because some of the methods are missing deep copy object and others, which are like generated ones. So what I am going to do is basically, so we've got some like, make targets, make reviewable will actually generate those methods and append it to those structs that we create. Yeah, it should be done. Okay, there you go. We've got all of them. So this should refresh in a minute.
I have lots of closing and reopening editors because Go modules and stuff does not behave super well in a lot of editors.
Yeah, I think when we build this will like be okay, but for now we can skip it.
Could you mention real quick about, so we see that generated deep copy, which I bet folks are pretty familiar with if they've done any kind of CRD stuff before, but for the generated managed and managed lists, where are those coming from?
Yeah, so these are standard functions that we use in Crossplane runtime. We generate them so that, because like, we use one reconciler and like, treat it as a composite struct where we, supply some functions to be called. And like, these are the functions that are required to be present on the CRD that we defined. So like, but like they're pretty generic ones, so we can just, we're just able to generate them automatically. Okay, so we have added this, and there's also one more step, which is like, when this manager is started, it has to add the new type to the scheme. So we will just do sub and okay. So when this like started, main.go starts, our scheme will be registered, and the controller runtime APIs will work. Cool. So we've got the CRD, and let me just run the make reviewable again, and we will see how YAML is actually created for us.
Looks like we have a few other folks in the chat now. Mocha joining from San Francisco. Hey, Mocha. Mocha does a lot for TBS, including live tweets a lot of times, so we appreciate her a lot. Phil, who works on Crossplane, joining from Seattle. Paul is joining from St. Louis, so fellow St. Louis in here. Paul actually runs the Go meetup here in St. Louis, so he does a lot of cool work around that. Jared mentions, what shell are you using? I'm getting a bit over my iTerm too.
Yeah, I don't know. I don't remember its name. I'll need to look it up, but like it was PowerShell X9 or something.
Gotcha. Maybe I'll find a link and drop it in there.
Okay, so as you see, we've got a few new folks here. This one. So you see the new files. This CRD is actually generated here. It's a long one, and like you just don't have to look at it. Like you will probably never need to look at it, except for for documentation reasons. You can just like go to CRD's dev and like see how it's structured. But like for now, it's just empty because we didn't define any parameters or observations. Cool. So we've got the struct, and now we will implement the actual reconciliation, like how we call GCP API. We haven't called it yet. So this is the controller directory. You see each group has its own directory as a package. So we will create the PubSub, and you can see we will say topic.go. And one thing not to forget is to copy this stuff over. All right. So when we have like a controller, first thing we do is basically to register it to the actual manager. In controller runtime, you've got like one manager per your executable, which is like Mangum in this case. But like all other controllers run as like different Go routines. So we have to set up and like register it. So when you look at IAM implementation here, you've got like a set up service account. We will just copy this function for now and like edit it. Cool. So let's go over it, and we can just say service account topic replace all. Some of the things will work, some will not. This will fix a few things. Okay. Oh, let me just close and reopen this. It didn't pick up the generated functions. Okay, cool. It's there now. All right, so I will come back to here like what happens here, but like real quick I can explain like we are creating a new reconciler. This is like main reconciler. We are just like creating another instance of that to use, and we're saying like, hey, this is the kind I'm trying to reconcile. This will be the external connector that we will implement in a second, and these are like logger to be to log in the standard output. With initializer, this is like new name, which will basically use the name of the CR custom resource as the external name of the resource. So basically, when I create a CR like topic CR within like my topic, the actual topic in the GCP console will appear as my topic. And with recorder is just like a standard one to publish some events to the for like kubectl describe output.
I think one thing that's really valuable here is you can kind of take this for granted if you haven't done it without having Crossplane runtime here. So in that complete method, a lot of times you'll see just passing, a reconciler struct or something like that. Here we're passing a function that returns a reconciler struct. But there is quite a lot of logic, which I think Muvaffak is going to show us later on as well. Yeah. But kind of all of these things we're passing in here just allow us to kind of override defaults. A lot of the defaults that come with this are really powerful. So you need to pass like the manage kind and the external connector and that sort of thing. But like the initializer, for instance, there are some defaults that come there, and we're overriding new name as external name here. But you can kind of do a lot without actually knowing what's happening behind the scenes. And as Muvaffak is going to show, you really just have to know your CRUD methods. And they'll be called appropriately for you.
Yeah, exactly. So I will just like come back and show like how this reconciler works. So here, first thing we need is a connector, which will initiate the connection to the GCP API. Like this is like the start of the reconciliation. However, one thing we need to do before that, as you see, this is like grayed out because it's not used anywhere. So we have to set up topic with the manager, which is done here. You see all the reconcilers setup methods. So we will say that setup topic here. We will pass the function and it will be called in this for loop. So coming back, so right now we have connected setup topic with the rest of the manager. So now we this will like literally be executed and it will call the connector. So we need to implement the connector. So this is the interface for controller runtime client, which will be used for like get, update, delete for interacting Kubernetes API. This isn't like GCP API, but Kubernetes API. And we will need a new PS client, let's say, or PubSub client. Okay, so this is where we dig into the actual API module. Let's see, because like we need a function that will create the client. We use, let me just show you an example from IAM. Okay, you see we are passing in a function instead of actual client because like during unit test, we want to be able to change it. So like we need to find the signature of the function from the GCP API. All right, so let's see. Go modules, here it is.
Yeah, I really like the, sorry to interrupt there, but I really like the interface of the connector here because it makes it pretty explicit, right? That what we're trying to do here is bring together these two different APIs. So Crossplane is bringing your Kubernetes API to the cloud provider API. And it has like just one method you have to implement connect that then allows you to do all these create, update, delete methods. So I really like that. I think it's good design.
Yeah. Okay, so so this is the module that we're gonna use, but like there's a caveat with GCP. So in GCP, you've got like a few clients doing the same thing. So there's like usually there is like always one client that is like generated and like low level, and like it exists for all the GCP resources. And then you've got like some other clients that are like human written that you can use like their UX is like simpler. So, but like in some cases, the lower level one works better for you. So from the first glance, we see a topic go, and let's see. So I've looked into this client, but like it doesn't actually meet our standard because it's a higher level than the lower level one, but it doesn't have, for example, the get topic method. It has like topic iterator, gets all the topics, and then you have to find one from them. But like there is actually a simpler API here in API v1, and it is in publisher client. So if we just like collapse all, we will see the method. So this is like literally create topic, update, get, and like delete topic. Like these are the functions that we need. Okay, so we are going to use this one. So first what we need is, the client itself. So this is the client creation method. So we will just copy its signature here for our function number here. Let's see, so this is publisher. So my career is built on autocomplete, and yeah. So you've got so here, this should be cube, and this should be, so I will pass in the actual function from GCP API here, a new publisher client. I don't see the rest of the line, but I hope it's the one that we want. Yeah. Okay, you see we passed the function as a parameter, and yeah, and then like when I do the test, I can pass like another new client function that will just create my mock client. So like that's the reason that we are doing it. Cool. So the connector, so for a resource to be a connector, it has to comply with, it has to satisfy this interface. So our connector should implement this function. Let's see. All right, so now it is happy because connector satisfies with satisfies the interface that it expects. Cool. So the first thing we do in these functions is that, as you see, we get a resource called managed. This is like an interface, so it could be anything. In this particular instance, it will always be a topic, but we have to cast it so that we can access the parameters of this resource. So a lot of the times you will just see this line in all these functions. If you can, not this one. So it's basically mg dot, doing the casting topic, and if not okay, new is not type topic. So in the end, I will move these error strings to the here to have as a constant, like this one, but for now this should be fine. All right, so we've got our CR here. So the connect method is similar across all GCP resources almost. So I will just do a copy paste here and go over what's happening. Okay. So what's happening is that all managed resources have provider reference. And what I'm doing here is, well, actually, let's change this name to client. So what's happening here is that I get that, I fetch that provider from Kubernetes API, from the namespace name of provider reference here. And some of the error strings, maybe we can copy them over. I feel like 10 people watching over my shoulder writing code.
Well, I'm sure they're all very appreciative of the work you're doing. One of the things I wanted to mention here is one of the parts that's kind of verbose, I guess, are these errors at the beginning of each method we're going to implement here, where you're checking to make sure that it's a topic, and maybe confusing why you have to check that the type that's being passed every time is a topic. Well, it's because you're being passed something that satisfies a managed resource interface. So this is kind of like the price we're paying, right, for using a shared reconciler here. It's just guaranteeing that it's a managed resource. So this would actually work if you said the managed kind that we passed in was not of a topic, but then it would pass you something that's not a topic. So that's why we check it here. It really, you should theoretically never hit that error. But I do get questions about that sometimes. Why do we have to implement this in each method?
Yeah, that's exactly the reason. So we see this rep method is not, so we don't use standard errors because we've got a few nice utilities from package errors. That I will just copy over this import here. Okay, so just make sure you import the right module. Okay, so what this does is basically returns an error by prefixing it with whatever string you pass in. We do that so that we know where the actual where the error happened actually. All right, so we get the secret and its data. So we've got the JSON blob that is used for authorizing authorization to GCP API. Cool. So now what we are going to do is to actually create the client. See that new pops up client and C2X. So a lot of times you can just look up to other resources and see how it's done. Like you can look at gives us whatever is, yeah. So it's just like, an option with credential JSON and credential JSON, which exists in s dot data. What is this called? Okay, there you go. This is literally what we need. Cool. So this is one option, and we will also need another option to decide on the scope. This is not necessarily most of the cases, but it's just nice to get it scoped down, like what client can do, if like that's the only thing that it's going to do ever.
Yeah, so if you've ever used Crossplane before in Muvaffak, you can go ahead and keep plugging along here. But you've probably seen so we call our plugins for these different cloud providers. There's also a provider type, which is basically how you provide credentials to connect to the API. So what Muvaffak's doing here is saying, okay, we've seen an event happen for our topic object. So maybe it's created, updated, deleted, etc. To be able to determine what we need to do next is we need to figure out what the external resource, the actual topic on GCP PubSub, what its state is right now. So what we need to do first is use the provider ref on the topic, go get that provider object, and then on that provider object, which is kind of like your vehicle for having credentials, we're going to get the secret reference where you stored your actual credentials. So it looks different for different cloud providers. For instance, like for GCP, you may have your kind of like JSON for your IAM user. It could be that for AWS, you have your access key and ID, or for something like Slack, which we kind of have a toy provider for. It's just like a token or something like that. So we're basically just saying, use these credentials to reach out to the provider, and then we can do everything we need to at that point.
Yeah. So what we need at this point is to return an external client, which we will implement like CRUD methods: observe, create, update, and delete. So this is the interface. So what I usually do is, like, we've got a NOP client somewhere here that does nothing. Yeah, there it is. So we'll just copy this over. And this is our external client. Okay. So we need these prefixes for it to work. All right. So in order to call these methods, in order to call GCP APIs from these methods, we need a client. This is called client, publisher, client, and we will also need the actual Kubernetes client. Okay, so return. No, actually. So we will just return what we had. Oh. Cool. Okay. So sometimes these clients, they have interfaces, so you can just use an interface here and supply the actual object here. But in this case, we just sent the actual struct. Cool. So what happens is that after we connect, our managed central instance of our managed reconciler calls these methods as appropriate, whenever appropriate. So the first thing that I would like to do is to implement the create method, so that we can get a glimpse of what it looks like real quick. So as I said, we have to do this in each of these methods. Cool. So let's see, c.ps.create topic. When we look at this resource, you've got like a topic itself, an header, and some parameters. So in this function, we don't need the actual topic because we're gonna like fetch it in observe as well. So we don't need that.
Yeah, I think that's a great thing to point out. And you can observe this by looking at what happens in the manage reconciler and Crossplane runtime. But just as kind of like the simplest idea of what's going on here is we always call observe. So on every reconcile, we observe. So you can always guarantee by the time you get to create, update, or delete, whatever logic that you've placed in observe has led you to there. So you don't need to check if it needs an update or delete in most cases. I don't want to speak for all of them because there are some weird APIs where you have to do additional checks. But generally, in observe, you're going to determine whether you need to call create, update, or delete. And then based on that, actually for delete, you just delete when the object's deleted in Kubernetes. So that'll be called automatically for you. But generally, by the time you get to one of these methods, that's what you want to do.
Yeah. So for create, we have to pass in a topic object with a few parameters. That's where we, go back to our API type and, add some parameters to their structs. So to create, these are like, main specs. So these last three ones, that are not used. They're not, for public API. And the name. So in Crossplane, we use an annotation for external naming. It's not a field on the spec. So we will treat this differently in a minute. But right now, what we need is these three, parameters. So I go back to APIs, pops up, and topic types in the parameters. I just copy and paste it. As you see, we don't have the message storage policy. Let's see.
Yeah, and this turns out to be a pretty simple type here that we're going to be implementing. It looks like we just have one nested field. In some cases, there's going to be lots of nested fields. And we want to reflect all of that nesting in our CRD, even if you think that the cloud provider is doing kind of like excessive nesting, or you think you could flatten it out and make a little more sense. We want to reflect that directly, mostly because we want you to have the option for the same experience in Crossplane that you get in the cloud provider. So we generally will refer to this as high fidelity, where we're saying we want to reflect exactly the API that the cloud provider exposes, even if it may be a suboptimal experience for the user. We kind of defer that to the provider.
Yeah, exactly. So I just deleted the like other tags that we won't use, protobuf tags and stuff, but we have to have the JSON tags. All right, cool. So you see our parameters is there. So what do we need now? So basically we've got our parameters and like, our struct, but that is not accepted by the create topic. They want their own, struct, which is like we just copied over. So we just need to do a, simple conversion. So this is where we have the client's package with helper functions. You see every resource has a package here. So it's not on group level, it's on resource level. So we will create topic and it's topic.go. All right. Cool. So what we need to do is to generate topic, and our input is basically our parameters, topic parameters, and our output is the topic object that pops up once from us, right? So I just want to make sure we import the right package that create once. Okay, cool. So as you see, I have used a value type instead of a pointer because we will not make any manipulation on this struct. So we can just, get it as value. And this is like a declaration of the function that, hey, I'm not going to make any change on this. So it's safe to pass in. Cool. So let's create a topic and fill some of the fields. Okay, so first it wants the name and in a specific format. As I have mentioned, we don't have the name in parameters. We will get it from the annotations. So like when we call this, I will pass in the name separately. So I will just, say, hey, this is the name of this. And then, so it has a specific format. It requires the name of the resource, name of the topic, and also project ID. So, which means I will just, add the project ID here. All right, so for the rest of the stuff, example labels, it has the same type. And
Yeah, while Muvaffak's continuing to implement the rest of this kind of translation from the Crossplane representation to the GCP representation, I wanted to talk a little bit more about what he was saying about how we handle names. So you'll see earlier that when he was using the manage reconciler, he passed in new name as external name. And so what that means is, as he said, we used an annotation to handle naming. And what that allows us to do is pass in something like new name as external name, which is saying use the name of this actual CRD instance. So in this case, it would be an instance of a topic. Use the name of that as the name of the resource in GCP. And that's a lot better of an experience, in my opinion, than having a lot of objects that just have kind of like arbitrary names. And then in their parameters, they have different names. It helps us have a better one-to-one modeling of your resources in Crossplane and your resources on GCP. But we kind of also give you the escape clause of getting around that and setting your own external name in the annotation.
Yeah, so one thing I forgot to mention is that when we copy over these fields, there are like, some rules that we follow for like typing these. So we've got so when you go to Crossplane and our design docs, so here there is a section called, like, this document basically, like, talks about how our APIs, are shaped, like, what conventions we follow, and like how to structure the API types. So there's a section is point types and markers. That's like, how we decide like whether a field is optional. Like how do you say it's an optional field, or how do you say it's an immutable, or how do you say it's like a required field? There's like a short summary here, and I just apply them. So the labels are optional. So like figuring whether they're optional or not is kind of tricky in some cases, because like they're not well documented in all of the cases. So what I usually do is to go and look at the actual update call. If that contains that field, then it can be updated. Create topic. Yeah, you see an update topic request. Okay, so it can accept everything apparently. So we will just start by marking everything as optional.
Yeah, and it seems like that. Well, let's see, for marking them as optional for the update, that would be more checking if they're immutable, right?
Yeah, right. Yeah, that's correct.
Yeah. So what Muvaffak's doing here is the optional tag and immutable. Right now, immutable actually doesn't do anything with the CRD versions we're using, but we're basically declaring if you have to provide something on initial creation of the object. We'd like to, while like we could just say everything is optional, we could just not even have a structured schema at all and just say, when you create this, we'll submit it to the GCP API, and maybe it'll work, maybe it won't, and you'll get the error message back, which that's a decent experience. And sometimes we get that because you provide a configuration that's not available, that we can't check for in a schema. But what we'd like to do is have that check for the actual valid fields and that sort of thing at the API server level. So when you kube control apply it, then you know immediately if it's going to work or not. You don't have to wait for GCP to try and create it and fail. So that's what we're trying to do here. And the optional tag here, it's a little bit convoluted about what controller gen actually does here. We would actually see these fields as optional anyway because of the omit empty tag, but that's just the way controller gen treats it. But in general, as mentioned in that API design doc, any field that you don't have to supply at create time should have the optional tag, should be a pointer type, should have omit empty in the JSON tag. And then any of the ones that are not basically should not have any of those. So it should be not optional, it should be not a pointer, and it should not have the omit empty tag.
Yeah. So we just applied like the rules that Daniel mentioned. And I don't remember where, but like I remember that this was immutable, but I couldn't find it in the API reference right now. Okay, cool. So we use the string value function here because even though like this could be empty, we say like if it's an optional, then it should be a pointer type. Map is a pointer, this is like already a pointer, and this should be also pointer. So, but if the target type is not pointer, we use like some small helper functions that exist in your provider repo. So this is like the whole conversion for this simple resource. As you see, we did not create this here because like in case of nil, we don't want to create an empty struct, which could have some bad effects that we don't expect. So we make sure that it is not nil, like user actually did fill that struct up, then we create it. Right, so here we will just call this generate topic. Okay, so here we need the project ID, which we don't have in this context right now. So I will just add it here and pass it from above.
Yeah, I like the idea of adding the project ID in the external struct here. The other option would be that whenever we need the project ID in each of these methods, we'd have to once again go get the provider again and get the project ID off of it. But since we're doing the connect before calling any of these methods on every reconcile, we might as well just go ahead and store it in the struct, and then we can access it on all these methods on the external object there.
Yeah. Okay, project ID name. So this is project ID. Okay, so this is the function that we use to get the external name that Daniel mentioned. What this does is basically get it from the annotation. So like in the end, I will talk about this a little bit more, but like for now, we will just use it. And this receiver could be E. Cool. So we have created it now. Oh, and so we've got the conditions. So when you start doing creating, we just mark it as creating. This will show up in the status of the CR as to let the user know that a progress is being made for creation.
Yeah, and that set conditions there is one of those methods that Muvaffak mentioned earlier that we were generating for you. When you run make generate, I think it's in ZZ_managed.
Yeah.
And so you just get that out of the box.
Yeah. So we have created the topic. So we will just try it. So here I am in the Crossplane repo. So here we've got like a few developer tools, including like for local tests. So I will use kind clusters. This will get me a new one. Meanwhile, let me just build the Crossplane because I will install it. Okay, so here my local cluster is coming up, and here Crossplane is building. So this is like Crossplane itself is building, not the code that we wrote. So we're just preparing the cluster for our experiments. So meanwhile, we can just look at what's going to happen. What's going to happen is, so external client. So this reconciler that we initiated, this is the reconcile loop that will run in each event. What happens is that we call the get here from Kubernetes API to get the managed resource. So see, this is all generic and used by all resources. And first thing it does to call the external connect method that we supplied. Then there are some initializers external name initializer and stuff, and it checks if it's deleted. If it's not deleted, there's resolve references function call here that we will come back to later on. So the first call is observe, and in the observe, it returns an observation. And this is critical because observation has a field called resource exists, and if this is false, or this was deleted. Okay, so this is what happens in case it's deleted. We're not there yet. Publish connection, finalizer. Yeah, here it is. So if resource does not exist, we call the create, and only in this case we call the create. So what will happen is that since our observe is just an empty, returns an empty observation, resource exists will return false. So we will continuously try to create the resource, and we will see this in the error. Okay, so build is okay. So other command that we have after calling up is helm install, which will install the Crossplane that we just built in our local machine, in our laptop. All right. Okay, we got it. So I have a few aliases. ed is making sure the namespace is Crossplane system. K is kubectl, G is get, and P is pod, essentially. So kubectl get pod. So I've got the Crossplane running in my Crossplane system. Cool. So, okay, the cluster is ready. So first what we need to do is, as you remember, we have generated the YAML file here, the CRD. We will go ahead and actually apply this whole folder to apply all the CRDs. As you see here, we've got our new CRD registered to the API server. So when we start the controller, it will it will not crash because it's there. Cool. So cmd provider and main and run. Let's see what's gonna happen. We will update these comments later on.
Also, just to mention this, Muvaffak is running this from his IDE here. There's also now a command where you can do make local dev, which is going to basically do everything he just did, except for it's not actually going to get Crossplane running, because when you are running a provider by itself, they can actually be run standalone. And as you can kind of see here. And so what it'll do is install the Crossplane CRDs, because some of those are registered in the scheme by provider-gcp, but it's not actually going to get the pods running, and it's just going to start the controller here for you. There's also a make local clean, I think, or make dev clean, and it'll clean that up for you. So that's another quick way to get this running.
Yeah. So I just create a YAML file, and I'm filling up some properties test. This is my labels. All right, so yeah, we will just create this and see what's going to happen. Okay, I just know where it is. Examples and topic YAML. Let's Let me just do a last check. Oh, so I didn't actually set up my credentials. So I've got a small script here. I will create a secret and a provider for me, and make sure that, like, whatever service account you're using, it has the permissions to create and, like, manage the pub subtopics. Like from, like, in the GCP console, you have to enable that permission for the service account. Right, so I've got the provider GCP now, right? Yeah, GCP provider, and that's what I'm referring to here. So I will just go ahead and create the topic. Cool. So I've got the event. All right, so I've got some errors saying it already exists. So let's see in GCP whether it came up. I hope you don't see anything confidential.
Our vital Crossplane playground account that has all of our critical workloads in it.
All right, here it is. So we've got it created. But as we expected, it continuously tries to create it because observe says, hey, the resource does not exist. So the next thing we do is to implement the observe method. Let's stop this. This is literally the same copy and paste. Okay, so actually, like, for as we did for others, you can just, take a look at another example resource and see, like, how it's implemented, and, like, just get some clues about, like, what is expected. So actually, I would like to look at, Cloud for this one. Okay, so first thing we do is, like, get, like, fetch it from the GCP, obviously. So topic ERR. Okay, e dot. Okay, so get topic request. It has a format. So I know some of you are, like, have some cringes when you see that I just use this, same format in more than one places and not use a constant, and that's because, like, it's just basically not worth it. Like, this is so constant, it's never gonna change. So it's not worth the redirection of, calling another function, because, like, humans are gonna read this, and, like, you don't want to click to another function just to see how it looks like for such a simple thing. So what it expects is project ID and external name. All right, so there is a detail here, important detail that so basically, in case, like, so there are errors that get can return, and the one that we care is not found error. So how it works is that observe gets the resource, and if it is, like, if the type of the error is not found, then we say, hey, resource exists is false. Then the create method is called. However, like, this is not an error case for us. This is, like, usual flow. So what we're going to do is basically skip if it is, like, not found error. So we've got a utility for this, ignore. So okay, so this ignore uses the supplied function to check whether to ignore the error or not. So in case, like, the error is not found, then no error will be returned, but external observation resource exists will be false, so create will be called. If it's, like, another type of error, then it's like, error will return and create will never call. It will just, like, return to the beginning of the reconciliation. But there is a catch here, like, at every managed resource, you've got similar things. In this case that I stumbled upon was that this is error not found implementation that we have in GCP. Doesn't really work for that because it's written for HTTP protocols, and apparently PubSub client uses gRPC. So I have dug into that and implemented a similar thing. Let me just, okay, I'm lost here. Okay. So I've implemented a similar thing, but for gRPC protocol of that. Not found gRPC. So it's going to be similar. I will just take a look at where I got it earlier. Okay, so it's similar to something like this. Yeah, it's exactly this. So status is yes, gRPC. Okay, so like this, I mean, like after this episode, like I will open a PR, so you won't have to implement this or think about it, like you think about gRPC, but like, you know, you can ask about it, about such things in Slack and stuff. So like, you don't need to worry about this really. But like, yeah, there are like a few things like in every resource that could make you go crazy. So we are going to use this one. All right, so we made the right observation and like, you know, returned true resource access false if it is like, no, not found. But if there is no error, like it exists and it's there, so we will not go into this if statement. So what we are going to do next is a late initialization process, which is like, you know, a standard in Kubernetes API where, for example, let's say you didn't give any KMS key name parameter, but GCP decided that, hey, you're going to use the default one. So when you do get the resource, you get that information, like it says, hey, the KMS key name for this topic is like default, let's say, but it doesn't exist in parameters. So, you know, like, you know, what we do is basically late initialize, which means initialize, you know, with whatever, you know, decided by the provider after the fact that, you know, we created it. See, like we get the parameter and put it onto the like appropriate field if and only if the field is empty, because like the controller never manipulates the desired state of the resource, which is like spec. So unless user fills the field, we will populate it with whatever returned from GCP. If it did, like, you know, sometimes it turns empty, so we just don't touch it. Okay, so what we are going to do is to implement that helper function. So here we are going to make some changes on topic parameters, and our input will be PubSub topic, which is like, you know, value, because like we're not going to make any change on this one. We will just, you know, copy the values from that. All right, so as I said, like, you know, we will check the topic and see if something is there, but we don't have it. Only in this case, we will assign it to our parameters. So we will basically check one by one. So for labels, it's like, you know, for map, it is s.labels equals to 0, meaning we don't have any labels, and t.labels does have some, you know.
Yeah, labels are definitely, or anything that's a map is a little bit tough with late initialize, because it's hard to determine exactly what the user wants. So, you know, with late initialization, let's say in the case that there are no labels provided, and, you know, GCP, for instance, just arbitrarily always puts a PubSub :topic label on everything, then we'd late initialize that here, because we'd say, oh, you didn't provide any values, and this one happened anyway. That being said, if you did provide values, and then let's say we late initialize that one that GCP automatically added, and then you're like, oh, I don't want that there. I don't want that label there, or I don't want another one that I had already provided. Then we don't really know whether we should remove that or not, right? It's kind of hard to reconcile the state there, because it may be something that was put there and late initialized, or maybe something that's not. And this kind of goes back a little bit to how we handle optional values by making them pointers. The advantage we get there is that we can make a determination between providing a 0 value for the type and not providing the type, right? So if you don't provide the type for a pointer, then the 0 value of a pointer is always nil. So that tells us that you didn't want it. But let's say it's a string and you say, I want to provide an empty string. If you don't provide a string at all and it's a string type, then it's going to get the 0 value of empty string. If you want to explicitly provide an empty string, you'd add an empty string. But if it's a string pointer, then if you don't provide a string at all, you get a nil value. If you do provide an empty string, you get an empty string. So we can make that determination there about what the user's intention was. So that can get a little bit complicated with some of the different fields. But there's generally a quote unquote correct way to do it, at least with how we define our APIs. And that's also just building off what Kubernetes does as well. So we're not revolutionaries in that regard.
Yeah. So one addition to that is that like when we do the late initialization, so like in our managed resources, there are like, status sub resource, and the central like managed reconciler only updates the status. So if you make a change on spec, you have to take care of the updating, spec. In this case, what we do is basically, do the late initialize, and only if there's a diff, then, call the actual update, just like, in Cloud SQL. So we've got, CMP equal. So first we save the actual spec, like whatever it is there right now. So we say if CMP, so this, current spec with the new spec. So be careful here, because like this equal takes interface, which is like, anything, but like they have to be the same type. So like if not, it will just like immediately return false. Like it's gonna say they're not equal. So like both has to be like pointer topic parameters, and this should be pointer type parameters. So if there's like a diff, so what we're going to do is simply call the Kubernetes updates. So at this point, I have like, done a lot of things. Like I have made some observations. I have late initted, and the next step is actually filling up the status at provider. So we like, just like we have like spec for provider, which means like, this specification is for provider, not like Crossplane or like anything Kubernetes level. And in the status, we have like, hey, what is the status at provider? Like specifically in GCP. However, so like, I think this is the first one that I've encountered in provider-gcp, that the get topic, like there's like all the parameters here can be given by the user. So there isn't really observation, it's all parameters. For example, let's say you create Cloud SQL instance, like you get some, let's say like IP address to access, like that's something that you would write in status and like connection details. But like in this case, in this like topics case, there is just none. So we're not going to do anything, but we will, you see here, like depending on the state of the Cloud SQL, it says like, available, creating, or like unavailable and stuff. So what we are going to do is like, for the topic, existence of a topic resource means it's available. So we were just going to say, hey, this is available. And the last step is, as you see in the external observation, last two steps. So we've handled the existence. So we have to check if resource is up to date. If our parameters is like different than what's in there, what's in the provider, then we need to issue an update. To check that, we will implement yet another helper method. So it is. So this will not make any manipulation on either of the arguments. So they will both be just values. So for this to like, we can just like, check one by one with if analysis, but we can also do like, convert the topic object into parameters and then compare these two same structs, because the conversion, like, and we will use late init for this. So basically we will like, observe it will be an empty parameters. So when we call late init with observe that, so since this is all empty, what's going to happen is basically all these ifs will be true and they will be assigned to the parameters. So we've got like parameters. So this is like observe it parameters and this is like desire. So the answer for like whether it's up to date is basically return cmp.equal if observed is as same as this one. So they have to be the same type, as you remember.
Yeah, we really like the CMP library because it allows you to do some pretty custom quality checks. In fact, you can write your own and pass them in. So I think Muvaffak is going to talk a little bit later about references and selectors and that sort of thing. But basically, it allows us to say, ignore this field when comparing these structs, or have this certain operation that you do before you compare any of these type and that sort of thing.
Okay, so we have let the reconciler know that whether resource is up to date or not. And the last thing is connection details. So this is, this is not a must for all of the resources. For example, when you create a VPC, there is no connection details. But if you create a Cloud SQL instance, you need the, username, password, and other things. If you create a Kubernetes cluster, you need the kubeconfig. In this case, there is like, not really something very sensitive, but like how you like, one should think about it like how my application would connect to this resource. And in this case, like, I have seen like, a few clients that they use like service account, GCP service account, and the name of the topic. So that's what we're gonna, publish as secret, as connection secret. Let's just make a topic and this should be a byte.
Yeah, so whatever you provide in the connection details here, which you can also provide connection details in other methods, like on some you'll see us write connection details in the create method as well. For instance, if there's something that's only available at creation time, like if we generate a password for a database for you or something like that. One thing that I think is really intriguing here is that the connection secret writing is it's actually satisfying an interface as well for a connection secret publisher. And right now there's just one implementation for that we write it to Kubernetes secrets. But you could imagine that you could publish that connection secret to, another system like Vault or something like that is something we hear frequently. So it's basically just a generic way to say, this is the connection information that needs to go to whatever I store secrets in, where my applications are going to consume from. And in this case, it's usually Vault. I mean, it's usually secrets. Sorry.
Yeah. So I have just updated my topic YAML to have the right connection secret ref field, which points to a secret that the connection details should be written to. All right, so we don't get the already exists error anymore because like we are able to tell them whether resource exists or not properly. So let's see the topics here. Okay, it's the little one. Cool. So we've got the like it's available for use and other things. So we've got a secret. Let's see what's there. All right, we've got it. In fact, we can just decode it. Cool, we've got the name. All right, so what do you do now? We will delete the resource, but the thing is in Crossplane, the manage reconciler, like there is no delete implementation. So one might expect that it will just disappear, but that's not how it works. What we do is like this delete is only a request for deletion. So we will implement the delete here, but unless here like get returns resource exists false, the CR keeps CR is kept in the Kubernetes API. Like we basically guarantee that even if you delete and like GCP says, hey, okay, I am going to delete it, it may not be deleted. Like something that might get stuck or like some other thing could happen. So we confirm the deletion by checking whether it exists or not later on. So we will implement this one too. This is okay. Okay, there are a few modules that have like the same name. I'm a bit confused, but whatever. I will just copy over this line. All right, so we will return the error directly, but there is one thing that we need to consider. We need to ignore the not found error. Like when we want to delete, and if it's not there, then that's fine. That's not an error. So we're gonna ignore that error. Ignore not found gRPC cannot delete topic. Cool. So we have implemented deletion now. Let's see. Right, it's there. So I will delete it. And I will check here. Okay, it's gone here. Now Crossplane will confirm that it is indeed gone. See here, like for example, an event is published as like successfully requested deletion, but that doesn't mean it's gone. Cool, it's gone. All right, so we've got the deletion as well. So we've got like almost full cycle of the resource, you see. So last but not the least is the update. Okay, so for updates, it's not that different, but we will need a few helper functions because of how the API is structured. So don't forget that this update method is never called unless isUpToDate returns false. So we will test it by changing a label on the spec. In fact, like right now, if we change it, there will just be like nothing will happen. So we will make it happen. Update. Why is there two different? Okay.
Yeah, one of the things that can be kind of frustrating with updates is that sometimes, especially in GCP, I've seen actually, there's multiple calls for updating a resource. So there might be one thing to create it where you provide all the parameters. But then when you want to update, a lot of times you'll see this where the update method for tags is different for a resource. So that can be a little bit more onerous because you have to evaluate the actual. You can't just say like there is a diff, just send my spec again and ask GCP to make it so. More declarative approach there. Sometimes it has to be like more imperative, like update tags on this resource. And in that case, your helper methods have to be able to tell you, okay, yeah, there's a diff in the tags, or there's a diff in the Kubernetes version, for instance, in EKS. You have to do a separate call to update the version of your cluster. So sometimes that can be a little bit onerous. So that's something to keep in mind.
Yeah. So I have called the update method and the object update topic object. It says like you have to provide the full topic and you have to indicate what fields should actually be updated. Like this is one of the edge cases. Like some resources have that, like update mask. Some of them like just figure that out on the server side, like whatever. Like if it's same, don't update. If it is different, then update. But in this case, it specifically like explicitly asks for a mask. Cool. So we will implement a simple helper function for this as well. Okay, so I've got that implemented before because it's a little bit onerous to write it again, and we have already run out of time for some time now. So I'll just go over it. So what happens here is that we again construct our parameters from the observation, and then create the update request with empty field mask, which means do not update anything, and then we check one by one, like, hey, is message storage policy is different? If it is, then add it to the update mask paths. And if it's not nil, because it can be updated to nil actually. So we will, if it's not nil, we will fill the topic object as well. And if labels are not equal, then add the labels to the paths and then, update the labels here. Cool, so this will return us an update topic request. Oh, okay. So we need an observation here. So we will make a get call as well. So I will just copy it from here. But now we do not ignore the not found error, because like if we're here in update and resource is not found, then that's definitely an error. Cool. So we've got the T. Right, what's the problem? Enough arguments. So it's project ID, name, parameters. Oh, okay. Cool. So we have called update. In fact, we can just make it like this and okay, so we are able to, so one of the nice things about this errors.wrap is that if error is nil, it does nothing. It just returns nil. But like in this case, you don't have to, do the if error stuff. So that's kind of, cosmetically nice. Cool. So we've got the update as well. So actually, let's try and update it without this piece of code, and then try to see how it works. Start this one. In fact, we can just describe the topic and see the, okay, successfully requested creation. Let's see, yeah, it's ready. So what I'm going to do is edit the spec and add a label. See, we say successfully requested update of the external resource, which means this is called, but it just returns nil. So when we refresh the page, okay, you see there is only one label here. Let's see in the details to prove I'm not lying. Yeah. Cool. So we'll remove this and command. Now we will start this. Okay. There you go. It's updated the label and we've got it. Cool. So this is like, pretty much the, full-fledged controller that we write for one resource. There are a few things left. So like unit test, obviously you see here. So usually we write a unit, a topic, a unit test for controller. And usually we, like in some cases, we have got like tests for some functions here. But like in other cases where it's like really onerous to test and like, the logic is essentially the same, we don't write, client tests. But like as long as we meet the standard of like 80% of unit test coverage. In this case, we like I would write the test like these are not as big as others. Like I have seen horror in this Cloud SQL, like you won't believe it. Okay. You would cry for 2 days.
I have.
Yeah. Cool. So we've got, so we have the tests missing. Our API type is, I believe, complete. For the first time, observation is empty, but that is fine. Like, everything is configurable and there is no observation that it returns to us. So that doesn't happen in a lot of cases. For example, let's see, in service account, like you can only like provide these two parameters, and what you get is like, you know, email, client ID, whether disabled or enabled, and like, you know, other stuff. Right, yeah. And another thing, yeah, and one important thing, another thing is that everything works here, but this doesn't mean it will work in the cluster. So what we actually need to do is to package this up and run it as a proper, you know, provider in the cluster. So for this, I am going to kill my cluster because like it will deploy its own CRDs when installed this package and build this provider. Meanwhile, my cluster can come up. Okay, while they're doing those things, I would like to, okay, and by the way, the next step is basically opening the pull requests. But obviously, I mean, like you would have like one commit for everything is not a good thing that your teacher back in school would like. So don't do that.
Yeah, nice. I like this because we're going to go ahead and push up a PR here. And then you can also, since like, you know, the unit tests are kind of like just checking your assumptions later. You could also go ahead and, you know, ask for some review here and say like, I just want to make sure I'm on the right track. Or, you know, I've got everything, but these unit tests, can someone help me run some manual tests on this and make sure that I'm not missing anything critical? So I like that we're going to go ahead and do this here.
Yeah, so you've got, you know, you see we've got the template here, we've got some checklists. And in Crossplane, actually, it asks you how you tested it. So manually tested and recorded and will be published. And unit tests are missing. So it asks you a few questions here. Did you make reviewable? So I did not. And it will scream at me so bad. So this make reviewable doesn't only generate some Go files, but it actually checks for like a lot of linter rules, for commands, for like, you know, for like obvious simpler tricks that you can do with Go and all other things. And it's like, it's pretty useful, you know, make target. As you see, like it's like late initialize should have comment or be unexported, like whatever you export should be commented. This file should be like, you know, Go imports should be applied. And you know, these are the things for like specifically Go imports. It could be a little bit frustrating because you actually run the Go import, like it runs at every save on my IDE, but like what we expect is actually like, you know, an organization of imports like this one. So like this repo, the modules that are in this repo the package in this repo will be in bottom, in the bottom, and Crossplane runtime or whatever other repo that we use from this Crossplane organization will be the second, and rest of the packages except the standard library will be another group of imports. And the standard. So it's like standard, third party, same organization, and the same repository. So now it's not gonna, you know, say that it is bad.
Nice. Yeah, I think we can probably wrap it up here for today. Yeah. It's been a super informative thing that I'm sure we're gonna point a lot of people to in Slack as well. So it's gonna be nice to be able to come back to this and say, yeah, like if you want to implement something, we have this whole stream of someone doing a fairly complex implementation, and did it in under 2 hours. So I think this is looking really good. Before we wrap up, Muvaffak, was there anything else you wanted to mention? We definitely really appreciate you taking the time to join us today. And it's cool to see someone who's kind of an expert in this regard implement one of these.
Yeah. I mean, I think like that's gonna be helpful, and like there are obviously like a few things that we couldn't get to, like references and selectors. But like we've got the documents, and like we've got a lot of examples. I mean, as you can see, like many times I just looked up like to another resource, like to see like how it's implemented or like what is needed. So it's not actually like you don't have to do a lot of tinkering, as long as API is like not crazy and like similar to others that already exist. So yeah, thanks for having me today, and I hope it's going to be helpful.
Yeah, for sure. And for everyone in the chat, thanks for joining. For everyone who's watching this at a later date, we appreciate you tuning in as well. We will be back in 2 weeks with another episode of TBS. And we'll probably have Muvaffak on in the future again to go through some more complex topics in our providers as well. So everyone have a good rest of your week.